Welcome to Windows Presentation Foundation using layouts in WPF. My goal in this brief video is to introduce the 5 primary layout panels that WPF offers. Before we dive into the example, let's talk a bit about the layout system. If you want to get the most out of the layout controls, you need to become familiar with how the layout system works. Of course, there's plenty of documentation in the MSDN library to help you out, but for now, just remember that layout is a recursive system that ensures each and every element is sized, positioned, and drawn on screen. Now, it may sound obvious, but also remember that the more complex the layout you create, the more work you're making the layout system do, and ultimately, this can affect performance. So layout is not just about getting the UI looking the way you want. It's also about building a smooth running app. The layout system starts with child elements, maybe a button or a text box or, well, anything. It measures the element itself, and then it looks at any sizing properties that have been applied, such as width, height, or margin. Next, it looks at panel-specific logic. For instance, a stack panel can have an orientation of horizontal or vertical, and that'll completely change the location and, in some cases, the size of a control. With all this input, the content is arranged, and the elements are drawn onto the screen. As soon as something happens that requires the layout to be updated, maybe a new text box is added to the layout, the whole process starts over. Ultimately, I think the best way to get familiar with the WPF layout system is through simple experimentation. You can use any of several tools: Visual Studio if you're a developer, Expression Blend if you're a designer, or if you just want a simple interface to play around with XML, you can use XAMLpad, which ships with the Windows SDK. Let's go ahead and take a look at some demonstrations. Let's take a look at some of the applications that you could use to test out the different layouts in WPF. One, of course, would be Microsoft Expression Blend 2, which is a great designer-oriented tool for building user interfaces for Silverlight and, of course, WPF. Now, it provides the ability to use any of the layout controls. You'll find them over in the toolbox over here, the 5 controls that we're going to be talking about today, as well as the secondary layout controls. You can interact directly with the design surface, and for instance, if I wanted to add some columns to a grid, I could simply do it very easily, and it will edit the XAML. One thing to sort of look out for is if you want to become more familiar with the layout controls by editing the XAML directly, then this may not be your first choice, simply because it doesn't provide autocomplete or IntelliSense that you might be familiar with or used to from Visual Studio. Another tool that you could use is XAMLpad. Now, XAMLpad ships with the Windows SDK. It's a nice little lightweight tool that allows you to type directly in to the little editor, and you'll immediately get the results in the viewing window. You can't interact with the viewing window in terms of editing. All of your coding has to be XAML, and again, like Expression Blend, you don't get IntelliSense. It does, however, have one feature that the other two don't have, and that's the ability to explore the visual tree, which can sometimes be useful in terms of layout and when you're dealing with control templates. It's not something that we're going to need today, so we'll go ahead and minimize that and jump to Visual Studio. Because Visual Studio, if you want to get familiar with XAML by typing XAML, you really can't go wrong. Now, it is an interactive designer too. We can drag controls directly to the design surface, etc., but we can also edit the XAML directly, and we'll get IntelliSense, autocomplete, everything that we would sort of hope for. Now, we're actually not going to use Visual Studio for this demonstration, simply because I want to get through the 5 primary layout controls as quickly as possible. And so for that, we have a small little app that allows us to add buttons to each of the 5 distinct layout controls. Now, each page or each tab will feature one of the controls, and for each one we can control 1 or 2 of its properties, as well as control properties of the button that we're going to add. So let's just start without making any changes at all, and simply for the canvas, click Add to Layout. Now, canvas is the type of layout that is probably most familiar to most people because it bases everything on simple XY coordinates. So there's a long legacy of similar layout systems. Now, when I clicked Add to Layout, I did in fact get a button. It's way up here in the corner, and it's got a width of 0 and a height of 0 because I didn't supply any values. And so basically all we're seeing is the outline of the button. If I want to see an actual button, it's not going to get it from the canvas. It's not going to get any size from the canvas. So I need to supply that by providing a width and a height. And now I should get a button. Now it's up in the upper left-hand corner because I did not supply canvas.left or canvas.top. As soon as I provide those values, we should start to see the buttons appear in new locations. One thing that's interesting about the canvas is its ability to render content outside of itself. And so the default behavior for canvas is to clip to bounds. And what that means is anything that goes off screen as far as the canvas is concerned will not be rendered. I can actually demonstrate this better if we change the background color a little bit. And you can see that in fact the button is at 0, 0. It's in the far upper left hand corner. And if I'm clipping to bounds and I change, let's say, this canvas.top property, if I change it to -4 and add it to the layout, you'll see that in fact the button gets clipped off with the edge of the canvas. But if I deselect clip to bounds, then you'll see the button extends beyond the borders. Now, it doesn't allow the content to extend, it won't automatically appear on top of other content if other content is rendered above the canvas. So for instance, if I change canvas.left to -20, for instance, then I'll see the edge of it and it's going beyond the purple that is the canvas, but it's not being rendered on top of this grid over here because this grid over here is in front of the canvas in terms of Z order. So just a few things about canvas. But canvas is the most rudimentary of layouts. Everything is positioned at XY coordinates. Everything has a fixed size or a known size that you can easily control. But when it comes to designing a layout that is fluid and changing based on screen size or the user request, etc., it's hard to do with canvas because you need to do a lot of calculations and math to determine where things are going to be. So basically the limitations of canvas have led to all these other sort of innovations in terms of layout. So let's move along and talk about grid. Grid is perhaps the most useful of the layout controls, and in fact it's the default. If you create a new WPF application in Expression Blend or in Visual Studio, it will be a grid. You can change and take out the grid and you can replace it with anything you want, so you're not forced to use it, but that is the default layout control. So the way that grid works is in the beginning it's and sort of by itself sitting there with no modifications, it's going to be a grid of 1 row and 1 column. And so if I was to add a button to the grid, it would take over the entire cell, because that's the way that the layout manager works when it comes to the grid. Is when it has content such as a button that's in a particular cell, and that child content, so in this case the button, when it doesn't supply its own height and width, well, it's just going to expand to fill the cell. If I change the number of rows and columns, say I make the number of rows 4 and the number of columns 4, well, now I'm going to that button is now going to be resized, and it's going to fit in just that upper left row and column, because when I didn't supply a row and column value, it defaulted to 0, 0. So for instance, I could add some more buttons, maybe have one still at that same first row, it's a 0 based index, but move it over 1 column, maybe change the row, and now maybe change the column back to 0, and you can see how I have these buttons laid out. If I was to actually supply a height and width. So maybe I make a button of type 4040 and I'll put it over at row 0, column 2. It's going to appear up here, and it's going to respect the width and height that I requested. So WPF will always sort of cater to your request. When you specifically say that you want a control to have a specific width and height, it's going to do its best to make sure that happens. But if you're not supplying a value, then it's going to use the layout system to determine what the size should be. And so you'll notice here, as I resize the application, well, the grid changes size, which means that the other buttons, the 4 buttons, change their size to correspond with the changing cell size. But the button that I've created with a fixed size, it doesn't change. It moves along in its cell, but the actual size of the button is not affected. Finally, there's the values of row span and column span. And so, for instance, I could let's remove height and width, and let's put this at the last row but the first column, and make a column span of 4. It's going to take over and expand beyond the boundaries of a single cell and take up that whole bottom row. And this is really what adds a lot of the power to the grid layout control, because you're not limited to just fixed size boxes in a row column arrangement. You can actually span columns and span rows. Let's talk about stack panel next. So stack panel essentially is, as the name suggests, just a way to stack controls off of each other. The default orientation for stack panel is vertical. Again, if I don't supply any properties whatsoever and I simply click add to layout, I'll do it a few times to see that the buttons that are being created, they're as wide as the stack panel is, but they're having a height of 0, so we're just seeing the edges and the borders of them. Okay? If I switch to a horizontal orientation, well, again, these are the same buttons and they still don't have any width or height, so they're getting their width and height from the stack panel, and in which case the stack panel tells them that without a, in the case of a horizontal orientation, as we're looking at right now, if the button has no height, then it's going to take the full height. If we specify a height, let's say 70 or 60, then it'll respect that. And when we switch to a vertical view, then we should see those buttons, and it'll respect that size. Right? So when you're using stack panel, the first choice, of course, is, well, which orientation? Do I want the controls to flow from top to bottom or from left to right? And if then you pay attention to the size of the width and height in terms of your control. And as always, it's going to respect your wishes in terms of the sizing. So if we say 80 and 80, and we add several of these, well, it's just going to center it, since it's, even though it's vertical and normally would expand it to the horizontal bounds, it's not going to do that because you've set the width to 80. If we switch it, again, it's going to respect the size of the buttons that we created, because we asked specifically for 80 and 80. Wrap panel is similar to stack panel, and if we start with the wrap panel and simply click add to layout, well, we start getting a lot of these tiny buttons. Again, 0 width, 0 height, because we didn't specify it. And the reason that it can't take any sort of influence from the layout, in this case the wrap panel, is because the wrap panel is a control that is not going to influence its children in that way. And perhaps a better way to explain it is to see what it actually does. Let's reset this and add some buttons that actually have some size. Again, let's make these say 60 and 60. and then we'll add a few. The default orientation, by the way, for wrap panel is horizontal. So as we add them, it looks not unlike stack panel, only with stack panel, these buttons would have been centered top to bottom. And in fact here, they're starting in the upper left-hand corner. And of course, the real thing about wrap panel, as the name suggests, is as we add more of them, when it gets to the sort of bounds of the available space, it's going to wrap around to the next line. And if we change the available space, it will re-lay out the controls, wrapping them from left to right and then top to bottom. If we change it to a vertical orientation, then it will simply go from top to bottom and then from left to right. So we're still going to wrap to take up the available space, or using the available space, but it's a matter of which direction we go first and which direction we go second. Finally, the last layout that I'd like to talk about today is dock panel. And dock panel can be very, very useful. It's also a little bit strange in terms of its behavior. If we take and let's not even supply width and height, we'll just say that we want to dock to the left, and we add, well, we get a button that takes up the entire space. So it hardly seems like it's docked to the left until you understand the way that dock panel works. It takes the last added element, so order is very, very important here, and the last element to be added will fill whatever space remains in the panel. So now I say that, but remember that it's going to respect your wishes in terms of width and height. So if we specified a width and height, it would respect that. It wouldn't make it fill and ignore your wishes. However, since we aren't specifying width and height, it just simply docks to the left, but it fills so it looks like it's everywhere. And you can immediately see a difference when we add a second button. We'll add one to the top. We add it to the layout, and now we have left over on the left side where it belongs. Top is now taken over because it was the last control to be added. It is docked to the top, but since it was the last control added and it's not specifying its own width and height, it's filling up the available space. We'll move around clockwise and add one on the right hand side. Now it's taking over, and finally we'll put one on the bottom, and now it is filling up the space, and we have left, top, and right as where we would expect them to be. If we move around again and we add more controls, you'll see that dock supports multiple controls docking to the same location. It'll just treat them almost like a stack panel would by stacking them up. So if we add them to the layout, now I have a new left, and now we have a new top, and now we have a new right, and now a new bottom. And you can just see how it takes whatever space is left, the new control is added in there, and then it's shoved over to that side as soon as something else comes in. So for instance, if we add more to the left, maybe some more to the right, and this is what I mean by learning about these WPF layouts simply by playing around with them to see what they do. Right? I kind of doubt that you would ever need to design a layout that looks exactly like this, but it's very instructive in terms of understanding the way, in this case, dock panel works. I hope you've learned a few things about layout today, and I hope to see you again in future seminars and sessions. Thank you.